Hello and welcome to Physics Fun. In today's video, we will be solving JEE main question which was asked in March 2021, and the question is from laws of motion topic. So the topic of the question is laws of motion. It is in 11th syllabus. Okay, so let us look at the question. A block of mass m slides along a floor while a force of magnitude F is applied to it at an angle theta as shown in figure. So there is a figure given. There is a block, and block of a mass of this block is m, and there is a force F which is applied to it, and it is applied at some angle theta with the horizontal. Okay, so remember that if force is applied at some angle, then there will be component of force which will contribute to the motion. Okay, let us read the question further. The coefficient of kinetic friction is mu k. So there is friction which acts on this block. Let us say this is the floor. Okay, and the friction, since the force is in this direction, so the motion will be in this particular direction. So the friction will act in the backward direction. Let us call this friction as small f, and the coefficient is mu k. So there is coefficient mu k between this block and the floor. And then the block's acceleration a is given by, there are four options given. If you carefully observe the options, the first term is same. If you carefully observe, the second term is also same except this sign. So this is positive, this sign is negative, this sign is negative, this is first positive, second negative, again third positive, this is positive, positive, and negative, 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 and negative. So there is only this difference in the options. Okay, so there are two methods to solve this question. One is the standard method, which I'll tell you in the starting of the video, and at the end of the video I'll tell you the shortcut. So this question can be solved in less than 30 seconds. In less than 30 seconds, I'll say that this question can be solved between 10 second to 30 second. Okay, so I'll tell you the trick at the end of the video. So now we have this block. Let us draw the free body diagram of the block. So this is our block, this is the surface on which it is going to slide, or it is sliding. And since it is sliding, so there is a sliding friction F given by mu kn. We know this fact, that force of kinetic friction is mu times mu k, which is coefficient of kinetic friction, times the normal reaction. You should remember this formula, where n is the normal reaction. Okay, so now let us draw the free body diagram. How do we draw free body diagram? We draw the block, we draw all the forces acting on the block. So this is force F, there is one more force acting downwards which is mg, there is another force which is normal reaction n, and now we are done with the free body diagram. We have drawn all the forces. Now think of the motion. The motion of the block, as given in the question, it is under acceleration a, and we know that this is the force F. So the block will obviously move in this direction. So let us say the acceleration of block is a in this horizontal direction, and the direction in which the block accelerates, we take that direction as x direction and the other as y direction. Okay, so keep this in mind whenever you get have question like this, where there is a you have to use Newton's laws of motion and you have to draw the free body diagram. So in such cases where the object is accelerated, the direction of acceleration, we take that direction as x-axis, so that the question becomes easy. Now think of the forces. We have total four forces. This is normal reaction, this is force F, which is applied force, this is force of friction, and this is mg, and I think there are only these forces. Now we have to think of the forces which are in x and forces which are in y. So if you look at the x direction, or this horizontal direction, there is only one force, which is F equal to mu kn. If we consider the vertical direction, y direction, there are two forces, n and mg. Now what about this force? This force is neither in x nor in y. So for such forces which are not in our x and our y direction, we take the components. So let us take the component of this force. This force will have horizontal component, or x component, given by f cos theta. How did I get this f cos theta? So it is by simple triangle, taking the right angle triangle. Okay, let us draw the right angle triangle, and let us say the length of this side is f, let us say this is theta, and let us say this is x. So we can write cos theta equal to adjacent side upon hypotenuse, which is f. So from this we can write x equal to f cos theta. So this is our horizontal component, which is this, but this is the vertical component. And if in this triangle, so this is 90 degree, so we can write sine theta equal to, let us say this is y, so opposite side upon hypotenuse is sine theta. So from this we can say y equal to f sine theta. Okay, so many students don't know why we take this component as cos and this component as sine. So we should always remember that it is from this triangle concept, or it is basically the resolution of a vector. Okay, so I have already made a separate detailed video which is in obviously Hindi, and in that video I have explained how to resolve the vectors. Okay, so you can watch that video from the playlist about vectors. Okay, let us focus on the question again. So this component is f cos theta, horizontal component of f. This component here is vertical component, this component is vertical, so this is also vertical, and it is given by the vertical component is f sine theta. So we can write this as f sine theta. Fine. So now we have one horizontal, one vertical. So now we can forget this, now forget this, forget this. Okay, so now we have four forces. I can draw them separately again. Since this is basic video, I want everyone to understand this question, and that's why even if you have not studied this lesson, you will understand the whole solution, because I am telling you each and every detail of the solution, and at the end of the solution I'll tell you the shortcut. For those who know all these basics, you can directly go forward to look at the solution. Okay, so now we have these forces which are in horizontal as well as vertical direction. So in this direction we have f cos theta, in this direction we have f sine theta, in this direction we have mg, and in this direction we have mu kn, which is force of friction. Okay, so now look at the motion. The object is moving forward with acceleration a, so we should indicate the direction of acceleration a also in this diagram, and this is our block of mass m. So this is simplified free body diagram of the block. Now from this diagram we can say, since this block is not moving upwards, not moving downwards, it means these forces are equal. What does it mean? N plus f sine theta, this is upward force, should be equal to downward force. Why these forces should be equal? If they are not equal, then the block should move in upward or downward direction, and we know that the block is sliding on this surface. It means there is no upward and downward motion, so these upward and downward forces should balance. Okay, and that's why I have written upward force equal to downward force. Now think of this motion, which is horizontal motion. Since the block is moving forward in this direction, so this forward force should be more than backward force. So forward force, which is f cos theta, minus backward force, which is mu kn, this should be equal to the mass times acceleration, mass of the blocks times acceleration of the block. So this is basically Newton's second law, F equal to ma, where F is net force, and net force will be forward force minus backward force. Why I have done F cos theta minus mu k n? Why I have subtracted this force from this force? Because the motion is in this direction, so it means this force should be greater than this force, and that's why I have written f cos theta minus mu k n instead of this minus this. Okay, so you should remember that in the direction of motion the force will be greater. Okay, and that's why the motion is in that direction. Okay, and if these forces are equal, then there will be no motion, so there is no acceleration at all. But it is given in our question that there is acceleration a in this direction, and that's why I have written this equation. Now think of the first equation, second equation. We have value of n, and we can find that value of n from the first equation. So let us rearrange the first equation. N equal to mg, put that f sin theta on that side, so this will be minus f sin theta. This will be our first equation, or let us say 1 2. So let us say this is third equation, equation number 3, and put this equation number 3 in this equation. Let us say this is 4. So using 3 in 4, so what is our fourth equation? F cos theta minus mu k. Instead of n we will write this whole equation, and the whole equation is this much, mg minus f sin theta equal to, this is ma. Okay, now we will simplify this. Now in our question, what is asked? Then the block's acceleration a is given by, and these are the formula. Okay, these are the options. So we have to find this acceleration a. So let us simplify this term, or let us simply put this m to the denominator. So what we get is a equal to f upon m cos theta. Now let us compare the options also. Okay, look at the options and look at my solution. So I am dividing this equation by m, so f upon m cos theta minus mu k, and divide these terms by m, so this will be gm by m, so mm will get cancelled, upon f upon m sin theta. So now look at which option matches with our answer. So it was very trivial or very easy question, and I think our first option matches with our answer. So answer is option number 1. So this was the long procedure or the longest procedure to solve this question. Now I'll tell you the trick. Okay, I think all of you have understood this question from the basic. I have tried to include all the basic or all the fundamentals required for solving this question. Okay, now I'll tell you the trick. Those who already know all these basics need not solve this question in this way. Okay, this is the worst way to solve this question. Okay, since in an exam we have only 1 minute, and if I solve this question and if I take more than 1 minute, so that will not be beneficial for me. So we will solve this question in 10 to 30 seconds. How to solve that in 10 to 30 seconds? This diagram was already given in our question. So what we will do, we will work out everything on this diagram only. Now what we have to find is acceleration. So let us say this is the acceleration A, this is force F, this is theta, so we know that this is F cos theta, this is F sin theta, there is normal reaction N here, and there is mg downwards, and there is friction F, which is mu times N. And what is N? N will be this minus this, so N will be F sin theta minus mg. From this figure itself we have found this. Now since the acceleration is in this direction, so acceleration will be we know that acceleration is net force upon mass. So what is net force? You have to just find this net force, since there is mass on denominator of each of the option. And if you look at the option, only there is difference in the sign, minus sign. So now look at this. If my acceleration is in this direction, so my net force will be this horizontal force minus this force. So my first force will be positive force, this minus this, so first force will be positive. Look at the options. So the first term should be positive, so option 4 is wrong. Option 4 is wrong. Just by looking at diagram we can say that option 4 is wrong. Okay, since this force will have horizontal components, option 4 is wrong. Now think of the second term. Second term, this force minus this force, and this force is mu times N, force of friction. And if you look at the force of friction, the second term is opposite, so the second term there should be minus sign in the second term. So option 3 is wrong, since there is plus sign. So option answer will be from option 1 and 2. Now there is minus n since this force is backwards. Now what about this force? This force is mu times N, so you have to just find this N. And what is that N? We have already found it in the diagram itself, and it is mu F sin theta minus mg. So mu times F sin theta minus mg. So there should be minus sign here. I have not written correctly. It is mg minus F sin theta. Okay, so from this we can say that this option is correct. So just looking at diagram you can simply say that there is a minus sign in between, so this option will be the correct option. Okay, without doing all the mathematics you can directly take this answer as correct answer just by looking at the sign, since all options are given in this way. The best way or the safest way is to do this mathematics, and the shortest way, if you have done a lot of questions, then the shortest way is to do using diagram analysis only. Okay, that's it for the video. Please do like, share and subscribe to this channel, and if you think that these solutions can help you and your friends, then do share these videos with your friends also.